We're in Algebra 1 on Monday, December 10th. Go ahead and write the date on your notes, please. It is December 10th, 12/10. All right, today's lesson, 4-2, appropriate units. Just a note that we have a very, very short unit, so we should have our test by Wednesday. That means we have today and tomorrow of new stuff talking about units, and then the test is on Wednesday. There's no quiz this unit. All right, so example 1, quiet raise hand to read this one, to turn in your participation card. Josie. Thank you. Participation card. There it is. And you obviously get your XP, so thank you, Josie. I don't know why I cannot find you. All right. So let's underline some key things about this problem. I'm doing this one with you. You're going to be eventually doing them on your own. So we're finding a rate of volume of the concrete per area. So volume is going to be in the numerator, and area is going to be in the denominator. And I am going a little bit faster through this unit because we spent some time working on Friday and Thursday's content. So which of these has units of volume per area? And some of these you might not remember. So maybe you have to go back to the notes, 4-1 to figure out what is L? Is L a unit of heat, temperature? What was L? Does anyone remember with a quiet raised hand? L is a unit that measures, Andres. It is volume, yeah. So if you don't know that, write on the side. L measures volume. That's volume. So thank you, Andres. Turn in your participation card. Pass it in. Another thing that measures volume that I don't have in the notes is things like that are cubed, like meters cubed. That's also volume. Anything cubed is volume. I could have inches cubed. That measures volume. Although that's imperial units, and I hate those. Maybe centimeters cubed. Centimeters cubed. Anything to the power of 3 is volume that originally measured length. These all used to measure length, but when you take it to the third power, that measures volume. All right, so anything that has an L for the top, that's going to be correct. So it can't be B, it can't be C. I should do those in blue. It can't be B, it can't be C, because it needs to have an L or some volume unit in the top. So it has to be between A and D. All right, and it needs to have an area in the denominator. Area in the denominator. Sergio, go for it.
D.
It is D because, how do you explain that?
It's an area.
How do you know that km to the power of 2 is an area? Just know it? Okay. I can go ahead and try to do it for you. Can you turn in your card? Thank you. All right, so just like anything to the power of 3 is volume, anything to the power of 2 is area. So if I have meters squared, that's area. If I have, in this case, kilometers squared, km squared, that's area. Anything to the power of 2 means it's area. Anything to the power of 3 means your volume. So the correct answer is D. It is, and then let's all write this in our notes. L is volume per area. These were length per length, volume per length, length per area. This is the only one that has volume per area. All right, let's do example 2. Another quiet raised hand to read. Let's go with Jessica.
Peyton has to determine the rate at which the price increases as the mass of the strawberries his neighbor sells increases. What would be an appropriate unit for Peyton's purpose?
Perfect, thank you. Turn in your card. You can pass it in or walk it up to my inbox. All right, so Jessica read our problem. I need to figure out what goes in the numerator and denominator. What type of unit? Obviously, these are a little bit more interpreted, but what goes in the numerator or the denominator? Either one. So I'm talking about mass of the strawberries. I'm going to do that in orange, and I'm going to do price. Those are the only two really units I see, mass of strawberries and price. Which of those goes in the numerator? Which of them goes in the denominator? You have a 50-50 shot. Who wants to take a shot at it? Which of those goes in the numerator? Which of those goes in the denominator? Price, mass of the strawberries. Who wants to take a guess? Gunnar, go for it. You have it correct, yeah. Thank you, Gunnar. And in fact, you interpreted it a little bit too. Because I was just looking for price in the numerator, and you told me dollars because you looked at their choices, and you are correct. We should have price in the numerator, and we have mass of the strawberries in the denominator. And it's usually, the way that you figure that out is if it's the first thing that it talks about, that's usually going to be in the numerator, and then the second thing is usually going to be in the denominator. So price needs to be in the numerator. Which of these has price in the numerator? And you can clearly see that dollars is the price that it's talking about. This is a unit of volume. This is a unit of weight. So let's go ahead and cross out C and D. We need dollars in the numerator because that's price. All right. So now I have the question for you. Is it A or B? And you need to explain why. You can't just say it's A and then, oh, it was a guess. I need to know why you chose your answer. Anyone that has their participation card yet, what is the answer? Is it A or is it B? Jose, go for it.
B.
B, why?
That's right. The dollars from numerator and denominator is the mass of strawberries, so kg.
Okay, yeah, so it's mass, not just strawberries. And that's the correct answer. B is the correct answer. This is a unit of mass, or weight. Mass/weight. I'm sure there's some scientists out there that's saying, no, it's always mass. Weight depends on a few other things, and that's correct. It's technically only mass, but on Earth, if we're assuming that we're always on Earth, it can be a unit of weight as well. All right, so it's not strawberries because we're looking for mass. So it's not strawberries. All right, questions thus far? Did you turn in your card, Jose? Thank you, thank you. We're on the back. I should hear paper flipping over. All right, now we have different types of problems. So now it tells us the units of each of these variables, and we need to put those variables together to figure out what the correct units are. All right, so does anyone want to read all of this, including all 3 bullet points? Monse, go for it.
Consider the formula W equals FD, where W represents work, F represents force, and has units of newtons, kg times m, over 2s squared, and D represents distance, units of meters, m. So that's another good measurement unit.
All right, thank you, Monse. You got your XP for it. Turn in your card, please. So I'm trying to figure out the correct measurement for work. I'm trying to figure out the units for work. Well, the units on the left have to be equal to the units on the right. It's a fundamental rule of units in an equation. Units on the left equals units on the right. So I need to figure out what units are on the right. So F times D, I'm doing this unit times this unit because these are being multiplied, F times D. So I need to multiply these 2 units together. So I'm going to do that off to the side. I should have given enough room, but I ran out of room because these problems were so long. So let's go ahead and do our work off to the side. So I have kilograms times meters, all of that divided by seconds squared. That was our unit of newtons. That all is units of newtons. So that's our force. And we need to multiply that by D. We need to multiply it by meters. So this is now going to be multiplied by meters. And technically, when I multiply by anything, I'm multiplying by that thing over 1. So I can say multiply by meters over 1 if you like it that way. Maybe I can do that in yellow because you don't necessarily need to have that, but it's really nice to see how fractions multiply. So on the bottom, I can clearly see what? What are my units going to be in the denominator? Quiet raised hand. If you still have your card, you're raising your hand. S squared times 1, seconds squared times 1 is what? Quiet raised hand. Seconds squared times 1. What do I have for the units in the denominator? Anything times 1. Let's take a shot at it. Otherwise, I'm going to cold call on people that I see cards out still. All right, Julian. Oh, did you have your hand raised? Oh, sorry. We're going to give it to Jennifer.
Okay, second squared.
It is second squared. Yeah, anything times 1 is just itself, so second squared in the denominator, which means we can immediately eliminate B. It should have seconds squared in the denominator. This one has seconds. Okay, well now we need to multiply in the numerator. Again, if you see something like x times x, that's equal to x squared. The power of 2 counts the number of times you multiply. So if I have m times m, in the numerator I should have both kilograms and what else? People that still have not turned in their card, I need to hear from you. I'm going to be cold calling unless someone participates. You want to take a shot at it?
The square thing.
The square thing. So read it to me. It's kilograms. So say kilograms for me.
Kilograms times m squared.
Kilograms times m squared. And I'm looking for that. Kilograms times m squared. Well, that's kilograms squared. That's not right. Kilograms times m. That was the original one. Ah, there it is. Kilograms times m squared. So the correct answer here is D, because m times m is m squared. These two, and you can do a note if you have room in your notes, these two multiply to m squared. Thank you, Julian. Turn in your card. And last but not least, we have example 4. Let me give Julian and Jennifer your XP. Did I give Jennifer her XP? Let me check. I did not. Example 4. Quiet raise hand to read. If you still have not participated, you need to participate. Maybe you can read. That's an easy way to get your participation points in. All right, Eder. Cohen, do you want to read?
Sure.
Okay.
Power donated by P can be defined as a function of work donated by W, and time donated by T using this formula. P is equal to W over T. Work is measured in kilograms times meters squared over seconds squared, and time is measured in S. Select an appropriate measurement unit for power.
Perfect. Thank you, Cohen. You can turn in your card. All right, so I have work divided by power. Let's go ahead and fill in what the units were for work and power, or work and time, sorry, work and time. So work was this unit. So let's write that off to the side. Let's rewrite all of this off to the side. So I have kilograms times meters squared divided by seconds squared. Now I need to divide that by T. I just wrote W. I need to divide that by T. Divide all of this by T. Instead of writing it like this, I could write it all of this divided by whatever my unit was for T. But instead of doing it like that, I'm going to say divided by T. And you'll see why in a sec. T, what are you going to guess for T? Are we talking seconds, minutes? What is already being used in the problem? What should T be? Time. Quiet raised hand. I think we only have one person left. How many people still have their card? Is it just Eder? All right, Eder. One of these 3 units is time. We have kilograms, meters, and seconds. Which of those is time? Oh, I'm not choosing. Oh, are you already skipping to the answer? You are actually correct. It is D. So good job. But I'm asking for which of these units measures time? Kilograms, meters, or seconds? Seconds. There it is. So if I'm talking about T again, I'm going to be dividing by seconds. Since we have the answer from Eder, so thank you, Eder. It was D. Let's talk about why the answer is D. So thank you, Eder. Everyone can participate multiple times. We're almost out of here. We have 2 more minutes left. If I'm dividing by seconds, remember the rule for dividing fractions. This is divided by seconds over 1. It's keep it something something. Do you remember what your rule is, Andres?
Keep it, change it, flip it.
Keep it, change it, flip it. Thank you, Andres. So keep it, change it, flip it means I'm going to do the same thing. I still have kilograms times meters squared per second squared. Keep it, change it, so it's changed to a multiplication sign, and flip it, 1 divided by s. Well, now I have s to the power of 2 times s to the power of 1. If there's no power, you assume it's 1. S squared times s should be, you just add up all of the exponents, 2 plus 1. 2 plus 1 is 3. I should have s to the power of 3 in the denominator, and that is the reason that we have s to the power of 3 in the denominator for D. D is the correct answer. And I still have kilograms per meter squared in the numerator, kilograms per meter squared in the numerator. That is the answer for D. Are there questions? These are difficult, but the more and more you practice them, the easier they become. Go ahead and write your summaries now.